Hello students. So in last lecture we discussed about Rankine cycle superheated condition. So today we will discuss about Carnot cycle. So for that I am sharing this PPT with you. Now in Carnot cycle, here we can see this. This is the Carnot cycle 1, 2, 3 and 4. Now here we can see this, that 1 to 2 is a heating process in boiler, and that is isothermal. 2 to 3, in which we are getting working turbine, that is isentropic. Now here we are rejecting heat, that is isothermal, and this is for pump or compressor, it is isentropic. So two processes are isothermal and two processes are isentropic. Now this is the ideal cycle. In actual, if we want to apply it in actual case, it is very difficult, but between two temperature range it has the highest efficiency. Although it is not feasible or practical, but between two temperature range, Carnot cycle has the highest efficiency. Now which are the problem that we discussed? Here we can see that we are not completely converting this steam into water. Clear? So problem may arise during pumping. So in pumping we can see this, that here we have a mixture of water and steam. So it is very difficult to send it from the condenser to the boiler, because it is a mixture, and at that time it may get separate. Clear? So in place of pump, it may possible you have to use uh, compressor. And again here we can see this, heating at constant temperature, heating at constant temperature. So it is also very difficult in some of the region. Always heating generally, as in as you supply heat, temperature always increase. So to heat at constant temperature, it is very difficult. And also this problem, here you can see these are the isentropic, but in actual case it is not possible to expand or compress this working medium isentropically. So these are the some of the limitation. Now these formula you all know, we discussed at the time of Rankine. So formula will remain as it is. So procedure to find out efficiency remain as it is. In Rankine we discussed. So procedure is same, just method is little bit different. So which are the difference that we discussed? H1 HF at P boiler, H2 HG at P boiler. Clear? Now for HF, H4, here we can see that we can find out H4 by use of H1. We can find out H3 by use of second point. Clear? So first we will try to understand how to find out H4, but we require help of this point. So first we will find S1. Then on the basis of that we will compare S4 is equal to S1. And here we will find first S2. Then we will compare S3 is equal to S2. So let's see that. So for H4, first we have to find out S1. S4 is equal to S1. S4 is equal to this. So on the basis of that you have to find out X4, and on the basis of X4 you have to find out H4. Now for 3 point, I told you that for the point number 3 we have to take help from the H2 or second point. So here you can see for H3, first you have to find out S2, then you have to compare it, S3 is equal to S2, then after S3 is equal to SF, from here we have to find out X3, and on the basis of this we have to find out H3. Now we will solve numerical, so you will get more idea. So here you can see this, these are the two range given, 35 and 0.07. This is the table according to that. So H1 is directly found out. H at P boiler HF, at P boiler HF 1049.8. So it is easy to find out this. Then after, here S1 is equal to which formula I gave you. S1 is equal to SF at P boiler. So we will check it. SF at P boiler 2.7253. So here 2.7253. On the basis of that, we have found out all the ultimately we have found out the H4. Clear? And same procedure on the basis of H2. Ultimately we have to find out the H3. So once you got all the enthalpy, it is easy to find out efficiency. Just put the value of enthalpy, you can find out the efficiency. So I hope that you understood this properly, and thank you for listening me.